Today is the first of 2 days where we're going to study the perfect competition model. So we're going to take what we learned about firms' costs and firms' benefits, the revenue, and we're going to think about how we can put that together into a model of supply. Today we'll focus on the short run, and next week we'll focus on the long run. This model has a lot of parts, so it's going to take a couple viewings of this video probably to start to get things to digest. So I recommend rewatching the parts as needed, and please doing the review questions before coming to class to get the most out of the worksheets we'll do in class. So the perfect competition model applies to cases where all the firms are selling identical products. Anyone can start up a business easily. There's no fee or barriers to entry or exit. And all the firms are really small. So like the small country assumption, where the countries we studied in our trade model just had to take the world prices given, the firms are small here, so they will take the market prices given. So to make that a little bit more explicit, price taking means that the firms are too small to influence the market-wide price more than a negligible amount. So we have market supply and market demand here on the left, and they determine a P star for the market. And that P star, suppose it's 2, we carry that over to the firms, the firm sees that, and people will demand as much as the firm can supply if they sell at a price of 2. If they sell at a higher price in this region, no one will want to buy because they can go to another firm and buy for less. And in this region down here, with prices below 2, the firm could sell, but it'll make less money than it could selling at a higher price, so we just assume the firm never even considers those prices. The marginal revenue of the firm, which is a concept we're going to need to think about how they can maximize profit, is determined by their revenue equation, R equals P times Q. Now we said earlier that P is fixed. For instance, P was 2 on our previous slide. It's fixed by the market. Nothing that the firm does in deciding little q, their firm supply, will influence P. So we can calculate the marginal revenue analytically or graphically. Analytically, our revenue when we produce Q plus 1 units is P times Q plus 1. Our revenue if we produce just Q units is PQ. We can distribute and subtract, and we're just left with P. So we can see that the marginal revenue is always going to be P, whatever P is, some constant, in the perfect competition model. We can also see this graphically. I've graphed the revenue function PQ here on the right, and we can see that it's just a straight line with slope P as the equation suggests. And since the marginal revenue is the slope of this revenue function, the same way that the marginal product is the slope of the production function and the marginal cost is the slope of the cost function, we can see that the marginal revenue is constant and always equal to this slope, P. The goal of the firm, just to make things as simple as possible for our first model, is always going to be to maximize profit. And profit, as I hope you remember, is just revenue, PQ, minus costs, C. So they want to maximize this profit. And to think about how to maximize, again, as economists, we want to think at the margin. We want to think about their marginal costs and their marginal revenue. So suppose that their cost is down here. At this point, here I've highlighted in blue, and their marginal revenue is always going to be just P, which for them is fixed. Their demand curve is perfectly elastic. Suppose it's fixed at 2. In this case, would they want to produce more units, fewer units, or just stay the same if they had a higher revenue than cost? Clearly they want to produce more units because they can make profit by selling at a price of, say, 2, and their cost down here is, say, 1. So they'll want to, so we can put an arrow that points rightward and shows that they want to produce more units to make more money. Similarly, we can consider the case over here on the right, where marginal cost is high, say at 3. Marginal revenue stays the same, it's still 2. Here they're losing money by producing this unit. The costs are bigger than the benefits. The revenue is more than offset by higher costs. So we put a left arrow to signal that they want to produce fewer units. And you can see that anywhere here to the right of this point, the costs exceed the revenue, so we want to produce fewer units, and we can draw in many arrows pointing in that direction. Similarly, any point over here, like this, this, and this, the revenue exceeds the costs, so we put in a bunch of rightward pointing arrows. And only at the point where marginal revenue and marginal costs are the same do we really not want to start producing more or less. This is a stable point, so it's essentially it's the firm's optimal point. They're happy at that point, there's nothing they want to change, so that's their production choice to maximize profit. So when we do profit maximization, we can look at it numerically as well, although it takes a lot of work since we need to fill in a large table. But I want you to go ahead and pause the video right now. Please pause the video and fill in each of these 6 columns, and you should see that when marginal revenue exceeds marginal cost, the profit will be increasing down the table. You'll get to a point where marginal cost equals marginal revenue, and the profit will be maximized. And if you go produce beyond that point, where cost exceeds revenue, then you'll see that profit starts to decrease. So go ahead and please pause the video right now and fill in this table, and then we will move on to the next concept. Okay, thanks for doing that work. In case you want to verify your answers, I've filled in the table, and you can pause the video and check your work. But you'll see that profit is maximized at a choice of either Q of 2 or 3, but at the point 2, marginal revenue still exceeds marginal cost, so the firm will probably want to increase output to 3 before it sees that cost and revenue are equal, and they want to stop producing. This leads to our short-run supply curve. We see that the golden rule for profit maximization is that marginal revenue equals marginal cost. Marginal revenue, just in this perfect competition case, is equal to P due to that perfectly elastic demand curve. So our equation that we use that implicitly defines our supply curve is P equals marginal cost. P equals MC. A lot of the time this is confusing for students because they see a rule that says P equals MC and there's no Q in the equation. So how could this possibly determine our Q, our supply? And the answer is that while P is just going to be a number given to you in the perfect competition case, marginal cost will depend on Q. So marginal cost will really be a function of Q. You'll get something, a given like MC equals 2 times Q, and then our given for price will be something like P equals 3. So our golden rule says P equals MC. We set P3 equal to MC, 2 little q, and we can solve to get Q equals 1.5. So when the price is 2, our firm will supply 1.5 units, and that gives us our individual firm supply. There's one last thing to consider though before we use our golden rule P equals MC. If the firm can make more money by producing nothing and just shutting down, then the firm will shut down and just supply 0. So first we find the quantity produced under P equals MC, our golden rule. Then we find the profit, and then we compare that to the profit if we produce nothing, Q equals 0. Specifically, we can look at this equation to get a shortcut. So when Q is equal to 0, the variable cost will be 0, and the first term PQ will be 0, so profit just equals negative fixed costs. If Q is not 0, it's given by our profit maximizing level, then we can factor out a Q and see that profit equals Q times P minus variable costs divided by Q, or average variable costs, minus fixed costs. So the key for determining if our profit on the right hand side here will be greater than on the left hand side when Q equals 0 is whether this part, P minus AVC, is greater than or less than 0. If P is greater than average variable costs, we don't shut down. If it's less, we do shut down. So maybe it's better to write this in terms of the shutdown condition. If P is less than AVC, shut down. And we'll ask you to review that logic so that you have it memorized when test time comes. So So for now, don't worry if it doesn't all click immediately, but it's worth reviewing this part of the video if that concept is a little fuzzy. To summarize, if P is greater than or equal to the average variable cost, in other words, if P is up here, then we just produce where marginal cost equals marginal revenue at this point, and we get this Q, and we're happy. Similarly, if P is here, we produce at this point, get this Q, and we're happy. But if the price is less than average variable cost, when the price and marginal cost intersect, such as at this point, where we're below the AVC curve, then the optimal Q is right here, 0. So there's a bunch of points here where Q will be 0, and then once we get above marginal cost above average variable cost, then we get these points, and this is our supply curve. Marginal cost curve will implicitly define our supply curve. So our review questions: first, explain how, if marginal revenue is greater than marginal cost, a firm can increase its profit. Ask the same question about how a firm can increase profit if marginal revenue is less than marginal cost, and then put that together to get a rule for how we can know a firm is maximizing its profit. The second question is explain the decision of whether to shut down or not in intuitive terms, and then explain the rule in terms of our variables for whether a firm should shut down. And our third question is explain why firms in this model are price takers. And you'll probably want to go back and review the first few slides if you don't remember. Perfect competition is a large and complicated model, probably the second most complicated one we will see in this class. So it's worth putting in a little extra work this weekend and on Monday so that you can master this model and get it behind you.